Today we're going to review distance on the coordinate plane. Our objective today is that we can use absolute value to determine distance between integers on the coordinate plane in order to find side lengths of polygons. Before we begin, open the independent practice PDF file and copy down the table. We're going to complete the first two rows together. Pause the video until you're ready to move on. As we complete this table, make note of the x and y axes. We aren't measuring the length of these, but they will be important for identifying the coordinates of other points on our coordinate plane. Let's focus on line BI. This line measures the distance between point B and point I. I highlighted this on our coordinate plane. Let's begin filling out the table. The first point in the table should match the first point listed in our line segment. The first point listed in line BI is point B. Looking at the grid, point B has an x-coordinate of -2 and a y-coordinate of 3. Let's list these in our table. Now let's take a look at the second point. This point should list the coordinates of the second point in our line, which is point I. Point I has an x-coordinate of -2 and a y-coordinate of 0. To find the distance between 2 points, we can always count the squares separating them on the coordinate plane. In this case, the length of BI is 3 units. Today, however, we want to focus on another strategy for finding the distance between 2 points. Let's zoom in on our line segment. We can see that both of our points have an x-coordinate of -2. This tells us that our line will be vertical, because only the y-coordinate of the points, their height, changes. Now that we know this, let's ignore the x-coordinate and focus on the value that changes the y-coordinate. Notice that these 2 points do not lie in the same quadrant. Point B lies in quadrant 2, while point I lies on the x-axis. Because of this, we're going to add the absolute value of each y-coordinate to find their distance apart. Let's take the absolute value of 3 plus the absolute value of 0. Remember that finding the absolute value of a number measures its distance from 0 and is always positive. In this case, 3 is 3 units away from 0, and 0 is 0 units away from 0. Our values don't change. This again shows us that the distance between these 2 points is 3. Let's return to our table. We can record the absolute value statement in our proof column. Let's repeat this process for line BH. On your own, find the coordinates of point B and point H. Pause the video here until you've completed this. We can see that we're still working with a straight vertical line. Both points have the same x-coordinate. This means that we need to compare the distance between their y-coordinates. Because the 2 points are in different quadrants, we will again add their absolute values together. In this example, the absolute value of 3 is 3 because the point is 3 units away from 0. The absolute value of -4 is +4 because it is 4 units away from 0. This gives our line segment a length of 7. Double check your work by counting the number of squares traveled on the grid. Add our proof and distance to our table. The only other type of problem you may encounter is when both the points are located in the same quadrant. In this example, line GH has 2 points located in quadrant 3. This line is horizontal, meaning both endpoints have the same y-coordinate. This means we must find the distance between the 2 x-coordinates. If we use our previous strategy of adding the absolute values of the coordinates, we would get a distance of 11. If you count the spaces on the grid, however, we can see that this is clearly not true. When counting, I see that I should only have a distance of 7 units. The reason this happened is because we added the absolute value of 2 coordinates in the same quadrant. We added 2, the distance point H is from 0, plus 9, the distance point G is from 0. But these measurements overlap. Instead, we must use subtraction of the absolute values. Once we switch to subtraction, we quickly see that our proof matches the value we found by counting squares. Add this data to our table. In conclusion, when two line endpoints are not in the same quadrant of the coordinate plane, you need to add their absolute values. When two line endpoints are in the same quadrant, we must subtract their absolute values.